Hello and welcome to today's webinar, The 5 Benefits of Confirmed Temperature Initiation, or CTI, Digital Linear Heat Detection Technology. My name is Brenton Harris. I'm the Vice President of Sales and Marketing at Protectowire Fire Systems. One of my main focuses is to provide educational training to the fire protection community, both nationally as well as internationally. I'm a member of the National Fire Protection Association, NFPA, as well as the Society of Fire Protection Engineers, SFPE. Now, before we get started, I've got a few housekeeping items I want to cover regarding this presentation. First, today's webinar will be available on demand after the live session and will be emailed to you after the conclusion of the presentation. Next, if you have any questions during the presentation, please email those to info, at protectowire.com. Finally, if you scroll down under the presentation, there's a polls question. If you could let us know what webinar you would like to see next from Protectowire Fire Systems, we'd appreciate it. Let's get started. So a quick snapshot or agenda of what we're looking to cover today. I'm going to go over the construction and operation of digital linear heat detection. I'm going to focus on some of the confirmed temperature initiation, or CTI, features and benefits. Finally, going to cover some common applications for CTI as well as digital linear heat detection, and then time permitting, we'll do some Q&A and some wrap-up. Protectowire was the originator or the inventor of digital linear heat detection. That happened in 1938. So for over 80 years, we've been making digital linear heat detectors and putting them into the marketplace. Despite that history, digital linear heat detection is not as well known as spot heat detectors or spot smoke detectors. So we use this graphic to introduce the technology. And what it is digital linear heat detection can be most easily described as a continuous chain of individual spot heat detectors. Unlike some other linear heat detection technologies, it does not require a certain length or portion of the cable to be activated at a specific temperature. It doesn't do any type of temperature averaging. Think of it as a long linear switch. Now I'd like to take a moment to talk about the construction of our standard Protectowire digital linear heat detectors, or our PHSC product. We start with 2 spring steel conductors. These conductors are coated in a zinc to prevent any type of corrosive reactions. We then coat those in a heat-sensitive polymer, as you can see in the screen ahead of you. This heat-sensitive polymer is what separates a 155-degree Fahrenheit detector from a 356, from a 220. This is where the difference happens within the detectors. We then take those coated conductors with the heat-sensitive polymer and we twist them together so they're under a spring pressure. They want to come together. The only thing separating these is that heat-sensitive polymer. The next step we have is we wrap those in a polyester tape. That polyester tape does 2 things. It holds that twist in place, and with a consistent twist, we get consistent activation temperatures and reaction times. The other thing it does is it provides a nice shape and cylindrical shape for us to extrude the outer jacket over the top of that twisted pair wrapped in that polyester tape. The outer jacket, which we'll touch on a little bit later in this presentation, is nothing more than protection from the environment. So to recap, we've got our steel conductors. Then coat them in a heat-sensitive polymer. We then twist them together. And after that's twisted pair, we wrap them in a polyester tape, and the final item is an extruded outer jacket that covers everything. Now that we've talked about the construction of digital linear heat detection, specifically our PHSC, or the Protectowire Heat Sensitive Cable, I'd like to take a moment to talk about the operation. And in front of you, you're looking at 3 different graphics. The top graphic shows what a normal condition is. The end-aligned resistor conditions the circuit of whatever the supervisory equipment is or control equipment is. It could be a piece of Protectowire equipment, it could be an addressable module, it could be another manufacturer's conventional control panel. Regardless, it's
the end-of-line resistor conditions the circuit, the panel is clean and green, all conditions are normal. We then go to that middle graphic, and whether there's a break in the cable, whether a terminal block has come loose, the end-of-line resistors come out of place, regardless, there's an open condition, current flow stops, which registers a trouble condition or an open on the control equipment. The final event, which as you can see indicated by the flame, is where, as we discussed, that twisted pair of spring conductors wants to come together. The only thing separating that is a heat-sensitive polymer. When it's exposed to heat at or above its fixed temperature, those polymers start to weaken, dissipate, or melt, allowing those metal conductors to come into contact with each other and short out. That short bypasses the end-of-line resistor, allowing the control equipment to recognize the change and initiate an alarm condition. Now, I want to point out, if you're using Protectowire control equipment, which could be our line of conventional control panels or our line of interface modules, we have meters, alarm point location meters, that when they receive this information will tell you how far away the short is or where your hotspot is located in a zone. Now I'd like to take a moment to talk about our confirmed temperature initiation, or CTI technology, which is why we're all here in this webinar. Our CTI technology is the only multi-criteria digital linear heat detector. And what that means is that only heat-actuated events cause an alarm. We do this by utilizing thermocouple technology. Now that sounds simple, and it really is, and I'll talk about this in the next slide. But I want to focus on the fact that it's only heat-actuated events. And why is that important? If you remember in the previous slide, in the third graphic, it showed a little flame. And we said that when the detector, the standard linear heat detector, reaches or exceeds its activation temperature, the polymers melt, and it allows those string steel conductors to come into contact together. That's how it's supposed to operate, and that's how it typically does. However, mechanical damage, which is when the detector is pinched, crushed, pushed under a pallet, bent at 90 degrees during a bad installation, those are also situations that can cause those metal conductors to prematurely short out. So to eliminate those premature shorts or false alarms, Protectowire created our CTI, or Confirmed Temperature Initiation technology. What we did was we took two existing technologies. We took our standard digital linear heat detection, which is tried and proven for over 80 years, and we made a detector that actually forms a thermocouple. And thermocouples are tried and proven. They're in industrial applications. They're used for temperature measurement within industry. And for those of you who are unfamiliar with thermocouples, a thermocouple is when two dissimilar metals are joined at 2 points. And the dissimilar metals produce a voltage relative to the junction temperature at that point. Prior to going any further about how we use the technology, I want to pause for a second and talk about the construction. Now, from what we just discussed earlier with our standard digital linear heat detection, we had two spring steel metal conductors. As you can see here, we've got a spring steel conductor that has a copper coating on it. And then underneath that, you've got a constant hand conductor, which is a specialty alloy that is a copper and nickel blend. So we've got those two metal conductors. We then have a heat-sensitive insulation or heat-sensitive polymer, very similar to the standard product. We twist them together so they're under a spring pressure. We've still got our polyester tape, and then we extrude an outer jacket over the top of it as protection from the environment. Now, for anybody who knows anything about thermocouples, which you realize what you're looking at here is specifically a Type T thermocouple. So moving forward into how it works and how it operates, can take a look at the CTI operation. Now, because our CTI linear heat detection cable requires the use of our CTM 530 interface module, which I'll touch on in a bit, we got rid of the normal condition that was shown in the previous slides with operation. So we're going to move straight into an open condition. An open circuit, which would be when current flow stops, again, is when there's a break in the cable, a terminal strip has come loose, or an end-of-line resistors come out, something of that nature. Anyway, that creates an open fault. This middle graphic here is what is really important with the CTI technology, and it is what identifies it and makes it unique to digital linear heat detection. What you're looking at there is a short fault, but that's at ambient temperature. And what that means is that if and when the detector is installed in a space and it does get pinched, it does get crushed, a pallet gets put on top of it, during the initial startup and commissioning process, you realize that something happened during the installation process, the module is going to let you know. And what happens is it creates a short fault. How we do this is we've got a reference junction that is inside the module. As we spoke about, thermocouples require 2 junctions, and your field short becomes your second junction. That allows us to recognize the temperature out in the field, and it allows the module then to make a decision as to whether that is a short that is caused by mechanical damage or whether that is a short that is caused by heat. And in the third and final graphic, the detector functions the exact same way as our standard Protectowire linear heat detectors. Those heat-sensitive polymers begin to weaken or melt because of an overheat. The spring pressure of the metal conductors come together. That interface module recognizes the fact that there's an overheat, and it initiates an alarm condition. Here I'd like to cover the fact that these are our CTI detectors and the detection range that is available. If you note that in the bottom left, we start at 135 degrees Fahrenheit or 57 degrees Celsius, and we go all the way up to the green detectors there, which are 356 degrees Fahrenheit or 180 degrees Celsius. Now, this chart's available on our website for additional information, but I think there's a couple key points that I want to highlight about digital linear heat detection technology. One is that each of these detectors, like a lot of heat detectors, has a maximum and a minimum ambient temperature. This is critical when placing the detector into any application. In the bottom left, though, I do want to point out that our 135 XLT detector is actually approved to minus 60 degrees Fahrenheit or minus 51 degrees Celsius. Next, we're going to talk about the interface modules. Up to now, we focused on the CTI cable, its operation, construction, and other things. What I'd like to talk about now is the CTM 530 interface module. As you can see in the screen in front of you, we offer it in 2 different versions. It's the exact same module, however, one of them is a standalone, which can, if you purchase 1 or 2 or design 1 or 2 zones, can often be tucked inside of extra space, inside of a control panel, or maybe installed inside of another enclosure. And then we also have it available in a NEMA 4X or an IP66 standalone enclosure for a little bit more protection from the environment. The interface module here, as you can see, and we'll go from left to right on the bottom of the module, there's different types of outputs available. So in the bottom left green terminal strip, those are the 4 to 20 milliamp outputs. And what that offers is status and alarm point location for our more industrial users. That center terminal block is actually what holds our Form C contacts. That's your general fault, alarm, and short fault. An important thing to note here is the general fault relay is energized. So if the module loses power, that relay drops out, and whatever is supervising the module will know that that detection circuit has gone offline. And in the bottom right-hand corner, that last green terminal strip, that's our Modbus output, and that's Modbus via RS485. Like to point out that this interface module can supervise in either an A loop or a B style configuration, which is where your end-of-line resistor is out in the field or out in the application somewhere. That's field selectable, and it services or supervises up to 4,000 feet or 1,220 meters of detector. Because of the detector module's operation, it has integrated alarm point location, so you will know where mechanical damage or your hotspot is. The module will do that math for you. It's got LED status indicators, 4 to 20 backlit display, and an event history. The event history can't be underrated because it helps any field service technicians or anyone else to understand what's happened in that circuit or in that zone over the last however long it's been until someone's visited. Finally, we touched on the NEMA 4X enclosure in the previous slide, and then it does require 12 to 32 VDC. Now I'd like to jump back into talking about the CTI linear heat detectors, specifically the jacketing material. So we're going to start with our PVC jacket. This is a UV stabilized PVC jacket, best kind of described as a multi-purpose, all around, suited for light industrial and commercial applications. Good to decent performance overall. Low moisture absorption and resistant to a lot of common chemicals. Decent flexibility at low temperatures. Our CTI 135 is specifically designed and was engineered for climate controlled environments only. And within those environments, we specifically targeted the refrigerated warehousing and freezer storage. It has excellent low temperature performance, low moisture absorption, and it's also the lowest initiation temperature of any digital linear heat detector on the market. It's also UL listed and FM approved and tested to minus 60 degrees Fahrenheit or 51 degrees Celsius. The third and final jacket material we're going to cover today is our fluoropolymer outer jacket. And whether you're an end user, you're a specifying engineer, or you're a distributor, if you don't have enough information about the environment where the detector is going to be installed, or you're just uncertain about a few items, this is the jacket to go with. It has excellent chemical resistance, excellent abrasion resistance, excellent weather resistance, high temperature, cold temperature performance. This jacket is really bulletproof and performs very well in a variety of applications. It's also FM approved for corrosive environments. Moving on, we can talk about our listed spacing for the detectors. Now, I think the first thing is when you look at this chart that you need to recognize is that our FM and UL listed spacing at a 10-foot ceiling height are different. As you can see from the chart here, our PVC, the CTI, the CTIX, which is the middle item, is the fluoropolymer, and the CTI XLT, which is the extreme low temperature version. They all have different activation temperatures and different listed spacings. The XLT is only rated for 135 degrees Fahrenheit. There is no rating for the detector after that. The other two, as you can see, as they progress on from 155 all the way up to 356. At 356, we have an asterisk. The asterisk refers to our FM approval, and that stands for proximity detection only. So any detector that's 356 or higher from FM is proximity detection only. What that means is you are on a transformer, you are next to a conveyor belt, you are around an engine system, something of that nature where you are in physical proximity to the hazard you are looking to detect. You'll note that UL, however, does give us a 50-foot open area listed spacing at the 356 degree level. And when you are looking at listed spacing and making or doing calculations, I want to bring up two items within NFPA 72 that are very helpful. First, like all heat detectors, we are subject to the spacing reduction up to the 30-foot chart in NFPA 72. The important thing to note is that spacing reduction happens by listed spacing. So if you use the same chart to run an FM spacing and a UL spacing for the same detector, you will get a different distance between detectors. The other item I want to address is sometimes there's misconception about being able to use linear heat detection in ceilings that are higher than 30 feet. There's a spacing exception rule within NFPA 72 that states that once you are over 30 feet, the detector can be spaced at 0.4 times the ceiling height as long as you do not exceed the maximum listed spacing. Having spoken in detail about our CTM 530 interface module, as well as our CTI series linear heat detectors and their different jackets, I'd like to move on and talk about some of the accessories that are necessary to complete the circuits and zones that use our CTI technology. We offer two different junction boxes that are compatible with this. And I say compatible because of the terminal blocks that are inside of them. Every portion of our CTI series field detection circuit has to be T-type thermocouple compatible. So those compression terminal blocks located in each of these junction boxes are a T-type compression terminal that allow the circuit to maintain the integrity it requires to give you accurate temperature confirmation. The box on the right is a 4 by 4 by 2 inch deep PPO thermoplastic box designed for indoor or covered spaces, not direct sunlight exposure. The box on the left is a 6 by 6 inch, 4 inch deep fiberglass HD or a heavy duty box. And you can see there that the compression terminal is track mounted in the back. Having just discussed the junction boxes related to the CTI series detection circuit, I want to focus now on some splicing connectors and the terminal block itself. Now, if we start at the bottom with the DRTB-T2, that is the terminal block that comes included with each one of the zone boxes. In the smaller box, it's free form and floating, and on the larger box, it's mounted on a DIN rail. This is necessary for all terminal connections within zone boxes for the CTI series. Now for splicing, you can use the CTI series splice connectors, which are those blue male-female pieces up top, and we offer those as a set. The important part with both of these pieces is that they are T-type thermocouple compliant. Using a regular copper compression terminal or some type of other splice kit introduces a different element to the thermocouple circuit and can induce what's called a parasitic junction and provide an inaccurate temperature measurement. So it is critical when using our CTI series technology that you use the correct splicing connectors and compression terminals. I would now like to take a moment to focus on our newest fastener that the Protectowire company has released. If you take a look at this, we're calling it the JD1 clip. And it works on ceilings. It can be pipe mounted should you put a strap through the 1/4 inch hole. It's fantastic for installing the detector. You can install the fasteners first and then clip the detector in. Should you require a splice or you need to repair a certain portion of the detector, you do not need to remove the fasteners. Now these are 304 stainless steel, great for any type of food processing plants where metal is required. It's a fantastic fastener. We just introduced it a few months ago, and it is gaining a ton of popularity. Now we're going to focus on testing. And this is a humongously important point for linear heat detection in general, specifically our CTI series linear heat detection. As per NFPA 72, Section 14, initiating devices, heat detectors, specifically fixed temperature, non-restorable line type, which is what Protectowire is defined at, a heat test shall not be performed. It's a non-restorable detector, cannot perform a heat test. However, with the CTI series, I'd like to point out here that we have a means of heat testing a non-restorable detector without destroying any portion of the circuit, allowing your AHJ, end user, or even as a distributor in the commissioning process, giving you peace of mind that the detection system is working as it should. We sell a temperature probe that fits neatly into the top of the DRTB, that T-type style compression terminal block that comes included in any of our junction boxes, that allows you to use either a heat gun or some other heat source to heat the end of the temperature probe, allowing the entire circuit to go into alarm. When that circuit is done and it's activated and gone into alarm, you can simply remove the probe, reset the interface module, and everything goes back to normal. I will caution, prior to setting any of this into alarm, please make sure any solenoids or any other items are offline, as we do not want any type of false or accidental discharge. Again, the testing and maintenance of linear heat detectors per NFPA 72 is remarkably simple and a huge selling point when evaluating linear heat versus spot heat detection for any application. So the webinar is titled 5 Benefits of Confirmed Temperature Initiation Detection, but we've got 7 here. And what I do want to focus on, at least for the CTI portion of it, is the first 5, because I think those are the most relevant. Short circuit discrimination. This is the only digital linear heat detector on the market that, when mechanically damaged, will not initiate a false alarm. This eliminates the need for double knock for double zoning, where you're running two linear heat detection zones in parallel because you're concerned about mechanical damage. Next, we talk about how it displays an alarm in short fault location. The CTM 530 interface module, which is necessary and inherent to the functionality of the CTI series detector, through that LCD display will give you distance and temperature information for either genuine alarm events or short faults, which equate to mechanical damage. Simple and reliable operation. As I mentioned previously, we have taken two tried and proven technologies. We've taken digital linear heat detection, which has been around for 80 years, and paired that with thermocouples, which are very proven and have a great track record within industry. Put them together into a new form of digital linear heat detection. Ease of installation, service, and testing. From an installation point of view, with the new JD1 clips as well as some of our other fasteners, that's a very simple and quick install. Service and testing. Per NFPA 72, you do not need to heat test this detection cable. However, with the CTI series, we do have a means of heat testing a non-restorable detector. And lastly, as a benefit to the CTI series, as well as a lot of linear heat detection, the detector is suitable for harsh environments and can be placed in close proximity to the hazard. Oftentimes, the closer you are to the hazard, the more likely there's a chance for any type of mechanical damage. With the CTI series being able to recognize the difference between mechanical damage and an alarm condition, it alleviates any type of false discharge of a foam system or a deluge system. And I think it's a major selling point for the detection itself. And the last two, the fast response and manufactured to the highest quality standards, I believe both of those apply to both our standard digital linear heat detection as well as the CTI series. Moving on, I'd like to talk about the industries in which you can find digital linear heat detection. Within those industries, which are listed here, the new construction and renovation, self-storage, animal housing, warehousing, petrochemical, power gen, as well as transportation. In a few slides from now, we're going to talk about some of the more specific applications. Right now, I'm going to jump into two that we don't cover in detail, which is self-storage and animal housing. Linear heat detection for self-storage is ideal, as there's often privacy concerns, as well as there is limited temperature control in certain facilities. This allows you to comply with NFPA 72 by having a detector that can withstand the elements and the temperature changes, but also takes into consideration the privacy concerns of the owners who have contents within those partitions. Animal housing for barns and stables specifically, linear heat detectors are wonderful as there's no concerns about diesel exhaust from tractors, cobwebs from buildup in areas, or any type of other concerns. Regarding construction and renovation, warehousing, petrochemical, power, and transportation, we'll talk about those in a few seconds. Historically, cable trays have been a tried and proven application for digital linear heat detectors. Between the long, extended runs, there's early overheat protection. Sometimes the trays turn vertically versus horizontally, and there isn't always access to where the trays run, or there's limited personnel in the areas. Having an automatic initiating device is helpful for any type of early detection. We've got two images here on your screen in front of you. The one on the right where the cable is kind of loosely laid in, do not prefer that as much. We actually like the one on the left where there's a sinusoidal pattern. And the purpose for that is if for some reason the hotspot or overheat in one of those cables starts in the middle of the tray, as it travels down or gets closer to where the detector continually crosses all of the cables, and inevitably will pick it up. We have helpful graphs and charts as well with spacing multipliers and things of that nature should you need help with any type of design or layout for a cable tray. Historically, conveyor belts have been a very common application for digital linear heat detection. However, when speaking with power gen companies or other people who service these, the only concerns they often have are downed conveyors or false deluge discharges due to mechanical damage or false alarms. The CTI system will enable you to retain that same type of proximity detection without your concerns for that accidental deluge discharge. And what we're looking for on conveyor systems itself is some type of systematic failure of the belt system, whether it is friction from belt slippage because of a bearing failure or a roller lockup, whether there was maintenance work nearby. It's often uncommon because of where the detector is positioned that it's going to catch the contents of the belt. And these conveyors could be for coal, for paper pulp, for some other type of material. This is an exact scenario where you definitely need to use the fluoropolymer outer jacket, that's CTI-X, as that will be robust enough to handle the abrasion, chafing, and vibration associated with being installed next to the conveyor. Another thing I'd like to point out is that within conveyors, whether it's a Class 1 Division 1 or an ATEX Zone 0, we offer interface modules that have ISB, intrinsic safety barrier capabilities. We also offer some conventional control panels where intrinsic safety barriers can be installed inside to allow you to maintain those listings or those levels of safety, but also have detection within those environments. Also like to talk about having messenger wire and having that used within covered conveyors. So messenger wire is a high tensile strength stainless steel wire that is wrapped around the linear detector once per foot or approximately 3 times per meter. Now this is used in cases where you cannot typically support the detector once every 3 to 5 feet or 1 to 1.5 meters as we typically suggest. And this could be due to inaccessibility to mounting areas, or maybe can't drill into the side of something. Using the messenger wire system, it's a series of turnbuckles and eye bolts. It allows you to put pressure through the turnbuckles and eye bolts on that high tensile strength stainless steel wire, and the detector is gently supported from that wire. So this is a great system for covered conveyors and or other areas using messenger wire where you need to get across larger areas where there's limited mounting abilities. Using linear heat detection within electrical compartments is another common application. It allows you to trace and follow all throughout compartments. It's the definition again of proximity detection. It's very low maintenance, it's rugged, and fairly easy to install. One item I'd like to point out for this is the importance of zone mapping, or knowing how much detector is in each cabinet and where that portion of detector is specifically located during an overheat. And the purpose of that is if you have several bus bars running side by side and you know that 10 to 30 feet is in one, 30 to 50 feet is in another, and 50 to 70 feet is in the third, well, when you do get an overheat condition and that alarm point location meter tells you exactly how far out it is, you need a zone map or some type of layout, think of it as an enunciator, to let you know where the problem is so you can locate and deal with that overheat immediately. Refrigerated warehousing and freezer storage is a very common application for linear heat detection. And when looking at how to best protect these facilities, we often turn to FM Datasheet 8-29. And within FM Datasheet 8-29, it states that your detection should be as low as possible for the given ambient conditions. This speaks directly to our 135 degree Fahrenheit or 57 degree Celsius linear heat detectors, our XLT or extreme low temperature detectors. Now for facilities that are looking at ceiling protection or ceiling detection only, we often suggest that you follow the sprinkler pipes. Now, I understand that this could be a contentious issue, and NFPA 13 speaks to absolutely nothing, that all non-system components should not be supported by the sprinkler piping. However, given that in this case, because it's typically a double interlocked pre-action system, the linear heat detection cable is being used as an electrical means of releasing solenoids on pre-action valves, and therefore becomes a controlling portion of the sprinkler system. Now, while that argument or that method is acceptable in many places, ultimately you need to follow AHJ approval. Moving on, for detection that is involved in the racks, I turn back to FM 8-29, as that document states that one line of detectors should be at each in-rack sprinkler line. So basically, for every row of in-rack sprinklers, you need a line of detection. And this is where we get into detector location. The Protectowire company recommends that the detector is placed on the back of the load beam and not on the sprinkler pipes that are in the flue space of the racks. And I'll tell you why. The flue space of the racks is a place where often pallets, boxes, other items can be pushed over by forklifts and end up falling onto the detector and the sprinkler piping. If the detector is on the pipes, in the racks, and a pallet hits, you can end up with a short on your linear heat detector. And if it's really unfortunate, the pallet could hit the sprinkler head as well, creating a low air condition. As we mentioned, these are double interlocked pre-action systems. You have a low air in your pipes, you've got a short on your linear heat detector, you're going to have water flowing into a freezer where there's no fire. This is why we would recommend the CTI series, confirmed temperature initiation, for this application. Even if the detector is physically damaged by that pallet falling, because there's no heat present, you will not initiate an alarm condition. Another common application for digital linear heat detection is aircraft hangars. And with aircraft hangars, we turn to NFPA 409. NFPA 409 states that a semi-annual functional test must be performed for all electronic detection. Knowing that you're going to be testing your detection system twice a year, using linear heat detection makes that job much simpler. Trying to use a scissor lift to get up to spot heat detectors that are 50, 70, 90 feet up into the ceiling twice a year is remarkably challenging, to say the least. When using linear heat detection, you can bring your end-of-line zone box down from the ceiling and place it in a convenient-to-access location that does not require the use of a scissor lift. Regarding spacing, I would like to remind everybody that it's from NFPA 72, we have the ceiling exception clause that can be used here, which is 0.4 times the ceiling height, but not to exceed the detector's maximum spacing. Another comment is about the size of the zone. With your linear heat detection zoning, we typically suggest that you pair it with the capabilities of the suppression system. Given the financial value of the contents of most aircraft hangars, historically we've seen detection zones that are cross-zoned or things of that nature. Whereas by using the CTI series, where only heat will cause an alarm, you do not need to cross-zone. Further, the short circuit discrimination will guarantee that you do not have a false alarm if there is any mechanical damage. And finally, as discussed earlier, by using our CTI series test probe, you can functionally heat test a non-restorable system. Providing temporary detection and protection for construction and renovation sites is one of the fastest growing applications for our linear heat detection. And what we're seeing is that as more jurisdictions around the country continue to embrace NFPA 241, that there's more and more implementation of temporary detection within these sites. Often for renovation sites, the spot detectors are removed and stored while the renovation is completed, but the building fire alarm panel remains active. Using our CTM 530 interface module that can be supervised by the active building fire alarm panel, you can then put the CTI series linear heat detector all throughout the site that's being renovated. And this image up here on the right is actually from a university dorm. And as you can see, the detector runs along the ceiling, it goes into each room, back out to the corridor, then back into the room, and so on. The nice part about this and the CTI technology is that it has that short circuit discrimination. So any mechanical damage to the detector comes in as a trouble and not an alarm condition, meaning that your site does not get shut down and or evacuated. The next application I would like to discuss is protection for floating roof tanks. But prior to doing that, I need to introduce our latest product from Protectowire, which is this retractable cable. We've offered a retractable cable in the past, but it has only had copper conductors. This retractable cable has both two constant-band conductors as well as two copper-coated steel conductors, making it compatible with our CTI series detector as well as our standard PHSC. Further, it is now available in up to 99 feet or 30-meter length. Prior to this, it was only 70 feet or 21 meters. Moving on to tank detection, I'd like to have you focus on the image on the right. And as you can see, we have the retractable cable there shows as the cord that goes down to connect the railing to the top of the tank. And the function of this retractable cable is as the liquid level within the tank changes and that roof floats up or down, this retractable cable allows the circuit to remain intact. At the bottom of the retractable cable is where the linear heat detector comes in, and that is typically run on the inside of the foam dam, but just above the weather seal, and it follows the circumference of the floating lid. Lastly, I'd like to point out that all of these areas are classified. So the use of our linear heat detection cable must be paired with an intrinsic safety barrier. And with our CTI series, as well as our standard Protectowire, we offer several FM-approved solutions. Today, we've covered a few additional applications in a little bit more detail. In the final slide here, I'm just going to talk about kind of the unique properties and areas where linear heat detection can be found. Whether it's the top of iconic towers, it's out west with the western part of the United States with the wooden railroad trestles to provide protection for bridges, subfloors and interstitial spacing or the space above drop ceilings, historic covered bridges in the northeastern part of the U.S., and the tops of cupolas and things of that for religious institutions. All of these things and kind of these unique applications are areas where you can look to and place linear heat detectors. And whether it's because they're simple to test, they offer the proximity detection, they have an extended service life or reliable performance, there's a lot of reasons that linear heat detections can be used in places that are often uncommon or difficult to protect.
Thank you for attending today's webinar. If you have any additional questions, please email them to info@protectowire.com, and we will definitely get back to you. Once again, I appreciate your time, and thank you.